Hi everyone, Towers of Hanoi. See, it is a Towers of Hanoi. Towers of Hanoi is a mathematical puzzle which consists of three towers and more than one ring in the dispatch. Dispatch. See here, it's come under the recursion. It's come under the recursion in data structures. Recursion is function call itself repetitively it function itself. When the base condition is satisfied, then function stop to call itself. See, that is only the recursion. It is a application of stack. See, what is a stack? Stack is called a last in first out. But here you can see in this diagram, this is a puzzle, but we apply the concept of stacks and we apply the concept of recursion. See here, there are three disks: disk 1, disk 2, disk 3. We call it, this is the largest disk, this is the smallest disk. They have certain rules, I will tell you that. Then see, these are the three towers. For example, we consider this is the source, this is the temporary, either auxiliary, this is the destination. See how the disk is located here. Same way we can shift it all this one to the here. But they have certain rules to transferring this disks to source to destination. Means this tower to this tower. See, there are rings are different size. The stack upon in a ascending order. The small one sits over the larger one. Small one sits the larger one. These are other the variations of puzzles where the number of disks increases but tower count remaining in the same. But it's clearly they mention the rings are different size. Then stacked upon into the ascending order. Therefore, the smaller one sits over the larger one. There are varying of the puzzle where the number of disks are increased, but the total count remaining the same. See, that is only, but we are applying the concept of stack. Stack is called a last in first out mechanism. Which data we added last, that only we removed first. Here also, which disk we added last, that will be removed. Topper disk will be removed first. See, that is only the towers of Hanoi. Means that is only the stack. Then come to the rules of the towers of Hanoi. See here, the mission is moved all over the disks, the same other tower without violating the sequence of arrangement. The mission is to move all the disks to same other tower without violating the sequence of other arrangement. The few rules of the following towers of an eye. Only one disk can be moved among the tower at any given time. Only one disk can be moved among the towers at any given time. Only the top disk can be moved. Only the top disk can be moved. No larger disk can sit over a smaller disk. No larger disk can be sit over a smaller disk. See, that is only the three rules. These three, once we apply these three rules, automatically it will be apply the concept of stacks. The following is the animation represented following the tower of the tower of an eye puzzle with three disks. See, that is only there are three pillars and three disks. See, tower of an eye puzzle with n disks can be solved in minimum 2 to the power of n minus 1 steps. This presentation shows that puzzle with three disks has taken 2 to the power of 3 minus 1 7 steps. For example, how to calculate? For example, it will be 4 means 2 to the power of 4 minus 1. 2 to the power 4 means 2 to the power of 4 is 16. 16 minus 1 is 15. 15 steps it will take to shift the data from source pillar to destination pillar. That is only. Then come to the tower of an eye. To write an algorithm for the tower of an eye, see, before the tower of an eye, first we need to learn how to solve the problem with less amount of disks, say 1 or 2. For example, we mark the three towers with the same. One is source, another one is destination, another one is auxiliary. Only to keep move the disks. If we have only one disk, then it can be easy to move from source to destination ping. See, tower, see, that is only source to destination, it's directly moved. When you have two disks, then it will be, first we can move the smaller disk to the auxiliary, means smaller one will move to the auxiliary, then we move the larger disk to the destination, larger move to the destination, then finally we'll move the smaller disk auxiliary to destination. That time the data will be shifted without violating rule, it will be moving the disk from source to destination. That is only first we'll shift this one to the auxiliary, then this one to the second larger one to the destination, then once again this one will put it into the ear. See, that is only the tower of Hanoi. Then come to the ear. So we are is possible to design the algorithm of the tower of Hanoi with more than 2 disks. We divide the stack of disk is 2 parts. The larger disk is a 1 part, other is n-1 disk can be second part. See, our ultimately aim is to move the disk n from source to destination and then put all the other disk on it. See, we can imagine the apply to the same, it is in the recursive way of all given set of disks. For example, step 1, move the n-1 disk from source to auxiliary. Move the nth disk from source to destination. Move the n-1 disk from auxiliary to destination. See, these 3 steps is very important. See, first we'll call that n-1 disk from source to auxiliary, another one is source to destination, see, another one is auxiliary to destination. Then come to the algorithm. See, the recursive algorithm means we can go for produce the disk, source, destination and auxiliary. If you have one disk, then it will be directly will move to the source to the destination. When it is more than n, that time we can call this source, auxiliary, destination, from source to destination. See here, source will be source, auxiliary will be destination, destination will be the auxiliary. Then another one is, see, after that tower of Hanoi, once we'll call the auxiliary will go for source, the destination will be destination, source will be auxiliary. See, that is only the step 1, step 2, step 3. See, what the procedure we are using here, same only we can adapt it that one, source to auxiliary, source to destination, source to auxiliary to destination. See, that is only we taken here. See, that is source to auxiliary, source to destination, auxiliary to destination. See, that is only we can implement a recursive function. Then come to here, we'll take 3 disks. See, that is disk 1, 2, 3. First one is smaller. We'll put it, see, this is called a source. See, this one is destination. See, source, either you take this one is source, this one is temporary, auxiliary, this is a destination. See, we'll put it A to auxiliary, then this one to destination. Then once again we'll see this one, first step is top disk will put it in the C, then once again another one will be put it in the B, then once again C will be put it into the B, then once again this top will be shifted to here, then once again here, then this one will be put it into the source, then once again this will be shifted to here, then finally this one will be shifted to final. See, once again, see here we applied all 3 rules. At a time we are picking one. See, smaller than larger disk, you can't put it in the smaller. See, that also at a time we'll pick only one disk. See, that one we apply the concept, this one, see, that will be shifted to the this one. See, step 1, 2, 3, 4, 5, 6, 7. Within the 7 steps, data will be shifted to when it is in the 3 disks. Then see another one, 4 disks. Once again, see here, same thing, they can adapt the concept, then shifted to all. Then once again, see how they're shifting everything like this. We can shift it. Then once again, this one will come here. This one will be, see, this one will be shifted last. Then finally, it will be shifting all the disks. See, that is only. Then come to here. The tower of Hanoi in the recursive tree, for example, first A, B, C, it will be go for C. This one is source, means auxiliary, temporary, then destination. So it will be source, destination and temporary. Then it will be destination, source, temporary. It will be shifting. The data will move to A to C, A to B, then B to C, then once again, here A to C, then C to B, then A to A, B to A, then A to C. So this is the way we can go for, we draw the recursion tree to shift the data from source to destination. Then come to the program. See here in the program also, in the main program we use the n number of disks, 4, 3, 2, anything, but here also we take it A, C, B, means source, destination and temporary. The return, see, once we will call this one, it will come to here, it will be n is equal to 1 means, so it will be directly go from source to destination. Either it is, the condition is false means, then it will call one more time source, auxiliary destination. So then another one is move to the source to destination. Either we call it auxiliary destination source. Then one more thing, why we use this one means this is called a recursion function. Function call itself repetitively, then parameters will be varying. Sometimes it will be source, the auxiliary will be act like a destination. But here auxiliary will be act like a source, then destination will be destination. That is only the program of recursive function. Then thank you. We'll watch other concepts in the next video.